Well, hey, everybody. This is Astronomy Daily Live. You can call me Cosmic, and it is 2 hours UTC. So it's time again for another live stream talking all things astronomical. And I already noticed that Tom is in the chat. Yes, all is well. I'm going to let folks gather in here a little bit because I just noticed something outside that I want to mention. But yeah, I want to let a few come on in first. So come on in. We do this every single day at the same time, same place. Now, once in a while, I'm not going to be able to do this live stream, and I try to let you know pretty far in advance if things, if that live stream is not going to happen. But I'm not seeing anything in the foreseeable future, at least. So yeah, every single day at 2 hours UTC, we are here, and I just noticed that Bobby has popped onto the panel. Hey there, Bobby. What's happening? What's happening? Bobby has joined. Hey, what's going on?
Yeah, I'm having a little trouble. For some whatever reason, the USB cables I'm trying wouldn't recognize it as an audio device.
Hey, these machines drive me insane. They drive me totally insane. And luckily, I usually have the magic touch. So usually when I get around them, they sorta kind of behave. I know many others where they just sort of get around a computer and it just goes insane, right? So anyway, I'm actually a little, my heart is beating a little faster and harder than normal, and in fact, I was getting a few goosebumps here a little while ago. Now, I've got to say that I have absolutely no idea, right? Absolutely no idea. But when I was out about like half an hour ago or so, before the sun set, before it set, I was looking to my northwest, maybe about, I want to say maybe about 35 to 40 degrees above my horizon. There at least was a very bright point of light that was at least not moving at all, as far as I could tell. Not in any kind of not in any kind of way at all. But the fact that I could see it when the sun was still up means that it's very bright. Now, when I first saw it, right, I was sort of like, oh, it's a reflection off an airplane. Well, it's not moving. It didn't move for at least the entire time I was looking at it, which was about 20 minutes or so. It did not move. Not even in sort of a sidereal way. So, so now I'm sort of thinking, weather balloon. I don't know. Now, look, I have been an astronomer my entire life. Okay, I have been looking up in the sky my entire life. Okay, I have never ever seen anything unusual that I can't explain in some way. Even if it sort of comes as sort of a startling thing at first, right? I mean, I've seen satellites re-entering the atmosphere. I've seen, you know, all kinds of planes in formation and you know, but I've never seen anything that I can't explain, right? So anybody I would say who is currently on like the west coast of the United States, it's starting to get dark, right? Uh, and even if you're, you know, anywhere sort of in the United States, right? I sort of encourage you to look to your northwest and see if you can see anything there. I would appreciate it. Bobby, I'm going to go ahead and mute you like that because I'm getting some feedback or something, and it's a little distracting. So I've got the coffee going tonight. Cheers to coffee, and I've got the dihydrogen monoxide just because could be an interesting night. The problem I have is that bright object is currently behind a very, very large cloud, so I can't see a thing. Now the thing is that probably what I'm going to do in about half an hour, right, is I'm going to very, very quickly run outside and take another look, because if it's still there, I mean, it's going to be really, 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 really bright. I mean, brighter than any planet, right? Any planet at all. So, you know, this could be a false alarm. I mean, it's not an airplane. Is it like a weather balloon? You know, some kind of instrumentation on a weather balloon, and it's just sort of, you know, floating there. That's possible. That's possible. But it could be something else too, right? And whenever I see a bright object in the sky, right, like a bright, you know, point source that I can't sort of immediately identify, it's extremely wishful thinking, but I immediately go to supernova. I'm going to check the chat here really, really quick. Let's see. Yeah, you know, it's I'm not quite sure. Not quite sure. It's raining at Atas. Bummer. Yeah, we actually had a pretty good monsoon storm overnight. There was a bolt of lightning that shook the house, woke me up, and that's not incredibly rare, but it was pretty loud. It was pretty loud. No, you know, I have never seen any kind of unidentified flying object at all. I've seen a lot of flying objects that, at first at least, it's like, oh, you know, what is that? But after a couple of seconds or a couple of minutes of observation, it's like, oh, okay, it's blah, right? Makes complete sense. Hey there, Uncle Bill. Nice to see you in the chat. Doing the penguin thing or the birding thing? So cheers. Anyway, just wanted to alert you all to the fact that there's a possibility that something interesting is going on in our sky, and like I said, you know, we as a planet, right, haven't witnessed a visible bright supernova for I don't even know how long, several hundred years at least, right? Actually, you know, let's start there. Let's look that up, just because. So I'm going to share my screen, and let's go over and see. Now I've got other things in my back pocket that I can talk about, but let's try to see when the last visible supernova was observed. So what I'm going to do before I do that, I'm going to start my I'm going to start my my stream on my smartphone so I can monitor that. There we go. Okay, so let's go over to Google, because Google is pretty amazing at this kind of thing. Let's just do like last visible supernova. So the most recent, let's see if we can pull this up here. The most recent supernova to be seen in the Milky Way was supernova 1604. Doesn't say how bright it was. Let's just punch on that. Kepler's supernova, visible to the naked eye, apparent magnitude of negative 2.5. So about as bright as Jupiter can get, right? Venus is about negative 4.5 at its brightest. Now this thing that I saw, as I said, I saw it when the sun was still up, right? So it's got to be like negative 7, negative 8. I mean, like super, super, super bright. So I'm kind of anxious to, and I'm trying to look outside right now, but it's sort of looking like that cloud is still in that spot. So look, the last visible supernova, right, was, what is that? 2018 minus 1604. That's 414 years ago, right? 414 years ago was the last time that a visible supernova was seen from Earth. So you know what? It is high time. It is high time that we have something like this going on. So those are the kind of thoughts that go through my head every single time I see like a bright, unusually bright in an unusual place object, right? I mean, so there was definitely something there. I actually did grab a few shots of it with my smartphone, so I do have a record there. Now, after the live stream, I'm going to go back out, and if it's still there, then this telescope and I, with my camera, my CCD camera, is going to collect data, because if this is some kind of astronomical event, it's really, 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 really important to have as much data that we can possibly get, especially early on, because it can tell us all kinds of things about what is going on there, right? So yeah, a little bit of excitement. Now, when I go back out and look, I'm not expecting to see anything. I'm expecting to see just a completely blank sky, nothing there at all. But if it's still there, it is going to be super, super bright. And as I said, I'm going to collect data as much as I possibly can. So, kind of a little bit of excitement here. I'm not that much of an excitable person, but when interesting things seem to be happening, you bet I can get pretty racy. So, cheers. So hope everybody else is doing really, really well. As I said, if you have a clear sky, really, go out, take a look to your northwest. If you're anywhere on the west coast, it's going to be, relatively high, maybe 35 to 40 degrees up. If you're anywhere east of that, it's going to appear lower, right? Lower in the sky. But yeah, see, I mean, if somebody can confirm that they too see something, then it is definitely not a local thing, right? Because if it was like a weather balloon or an airplane or something, then I mean, I would see it and you definitely would not. So yeah, interesting. Very, very interesting. Gets me a little bit excited. Gets me a little bit excited. Yeah, and Atta, that's an interesting comment there too, and don't know. So I'm just catching up on the chat. Okay, cool. All right, well, cool. I think probably what I will go ahead and do. I actually made a purchase for this system today, and actually I'm going to be making another one tomorrow. One of the things that's really, really, really important, regardless whether you're visually making observations of things just for fun, or if you're doing any kind of astrophotography, or if you're actually collecting scientific data, right? Is that your instrument, your telescope, has to be focused. And when you're looking at things with your own eye, you've got your hand on the focuser, and it's pretty easy, to look into the eyepiece and be able, to focus pretty quickly and pretty accurately. But when you've got a camera, like a CCD camera or a webcam, anything else, it can be a little bit harder because, to get just optimum. But so there's all kinds of tricks and all kinds of devices to aid with that. And so what I got today was one of those devices, and I'm going to let's just walk through this. I'll show you what I got. So this is called a Bahtinov focus mask. And what it is, you put this on the front of your telescope. So here I'm gonna stop sharing just so I can point to where you put it here. So you put it on the front, right on the front. Back here is the primary mirror, and then the secondary mirror is up front actually too. And then my focus is down here, right? So that's where I put either my camera or like an eyepiece or anything else, right? Well, this Bahtinov mask goes onto the front, right at the front. And let's see, I'll share my screen again. Hide that. So as you can see, this mask has this sort of peculiar pattern to it, right? And what what that does, in effect, is it sort of breaks up the light. It scatters the light from a bright star. So you want to point to a bright star. And then this mask will scatter the light into a particular pattern. And let's go over here. Let's see if I can Bahtinov mask. Let's see if there's a decent diagram here, just showing the process. Oh, there we go. Yeah. So hopefully you can see this. Let's see if we can zoom in on that a little bit. So what this is showing, this is going from way out of focus to way, you know, on one side of the focus to way on the other side of the focus. And what you notice is, wish we could pause this. Let's go back. What you'll sort of see is that when you're exactly in focus, yeah. So when you're exactly in focus, this diffraction spike, right, will be right in between these other two, right? You can sort of see here that this one's a little bit to the right and this one's a little bit to the left, right? So now let's go back to that movie thing, and you can sort of see there's a central spike that moves from left to right here. Yeah. So you know that you're perfectly focused when this spike is going right down the middle. And anywhere else, you're slightly out of focus, or in this case, you know, majorly out of focus. So this is a great thing to actually see. That really shows things off really well. So this is a great way to focus if you need to be exact. And you know, when I'm collecting astronomical data, right, I want to make sure that I'm exactly focused, exactly. And so this mask is definitely going to help with that, for sure. So that just goes onto the front of the scope. I do a quick focus check. I take it off, and I am ready to go. And you know, for 26 bucks, 27 bucks, it's a good deal. Good deal. And it'll be here in a few days. Hopefully. It is coming post office again. So we will see. We will see. But I've actually gotten a couple other deliveries here for work that made it here just fine. So yeah, it's pretty cool, you know, that this kind of a pattern will spread the light out in this weird way. And as I said, when it goes right in the middle like that, you know that you're exactly in focus. So that's a Bahtinov lens. Go ahead, Bobby.
FBI time, if it says deliver, but it's not. It's FBI time.
What's Tom talking about?
No, I'm saying that if you don't get it this time, I think it'd be better if you did call the FBI.
Oh, haha, yeah. I'm looking at the chat where they're talking about Ophiuchus, the constellation, and I think one of the reasons why Ophiuchus isn't a member of the zodiac was because when the zodiac was sort of established, Ophiuchus the outline of that constellation actually didn't go through the ecliptic. It's only sort of in modern times when those boundaries were sort of, established, that constellation did actually just barely sort of touch the ecliptic. In fact, let's take a quick look at that, huh? Because we can do it. Da-da, Ophi. Oh, how do you spell it? I don't know. There it is.
Ophiuchus.
Yeah, I got it. Yeah, there it is. So there's the ecliptic, right? And by definition, right, the constellations of the zodiac are those constellations through which the ecliptic goes. And as you can see, the ecliptic clearly goes through this constellation. But as I said, my understanding, now I haven't confirmed this, but my understanding is that when the constellations of the zodiac were sort of established, this boundary here, this southern boundary here, wasn't that far south. I think it was up here, right? It was probably pretty close to this bright star here. So maybe it cut off like right there. Now, I mean, I'd have to confirm that. But that's sort of my guess. And that this region of the sky was either part of Scorpius and or part of Sagittarius. Might actually even, they may actually even say something about that here in the article, Deep Sky Objects.
There's debate about maybe the 13th zodiac sign.
Yeah. Bobby, that was a complete robot voice. Yeah, okay, so it has been called the 13th sign of the zodiac. However, this confuses sign with constellation. The signs of the zodiac are the 12-fold division of the ecliptic, so that each sign spans 30 degrees of celestial longitude. Ah, okay. So,
well, what could happen to make that to be disagreed?
Well, as it said here, right? I mean, the zodiac is the sky divided up into 12 equal parts. So, 360 divided by 12 is 30. So 30-degree chunks make up the entire sky going around, 12 of them. So, yeah, it's just the boundaries. The boundaries are different. So, I mean, what we call a constellation, zodiacs are actually called signs, right? And signs are divided up into 30-degree chunks, as opposed to the constellations, which are, divided up by, committee. So, yeah, that makes sense. That makes sense. So yeah, it just so happens that yeah, it's just not a part of it. Interesting.
I think it was previously proposed somewhere around 2010-ish, but I think that still also got disagreed.
Well, that would mess up, everybody's well, not everybody, but 1/12 of the population of the planet would be completely confused because their sign would have changed. They wouldn't know who they are or what to do. So it just makes sense. Don't want to change that. You don't want to confuse 12% of the planet. That's a big chunk of the planet. Anyway, so that is what I just purchased today. And what I'm going to get tomorrow is this guy, which is called a focal reducer. And a focal reducer does exactly that. It reduces the focal length of your optics by a certain amount. Bobby, I'm going to go ahead and mute you again just because I'm getting some feedback. There we go. So what that'll do, right, is it will it'll effectively cut the focal length of my telescope in half, right? So instead of it looking like 1,000 millimeter focal length, it'll look like a 500 millimeter focal length. And what that'll do is it will increase my field of view by a factor of 2. So when I do a live stream with my webcam, we'll actually be able to see a little bit more, you know, a wider field of view. I think this thing will also go on to my CCD camera, which means I'll also have a wider field of view there too. So I think this is very, very cool. And yeah, it just, I mean, conventionally, as you can see, it just sort of screws onto the end of an eyepiece. You can look at the eyepieces you have and look in the bottom and see if there are threads. Well, if there are threads, this thing is just going to screw right onto there, right? Very, very cool. So yeah, even for a regular eyepiece, this will work. And the only thing that you have to do is you have to make sure that you have the right threads. So that's one thing that I still have to confirm, you know, that this is the exact one that I need. Definitely 1.25 inches, but yeah, I'm not quite sure about the threads yet. I'm gonna have to check that out a little bit more. But that'll just create a wider field of view, less magnification, right? I mean, I'm gonna cut the magnification by a factor of 2 as well. But I'm pretty interested in getting a wider field of view, especially on my CCD camera. The only problem with doing that, of course, is that my resolution is also going to be cut down by a factor of 2. So instead of what I think I'm getting about, I want to say like 1.2 arc seconds per pixel, I'll be getting you know, like 2.4 arc seconds per pixel instead. So cut back a little bit. No big deal.
You know what you also should get?
Say that again, Bobby.
You know what you also should get?
Your robot voice. I can't get you.
You know what you should get again?
What's that? What?
A Ring doorbell.
A what?
A Ring doorbell.
A Ring doorbell?
RING.
I don't know what that is.
The Ring doorbell. I know you probably don't have cable where you're at, but it was supposed to. It's planned to stop those packaging things from taking your package and stuff. So when you look at the camera and you say, "Hey, what are you doing?" and they'll just haul butt.
Oh, I gotcha. Yeah. Well, you know, the thing is that there isn't anybody out here to be a thief. There's nobody here. But yeah, that's an interesting interesting idea, nevertheless. Nevertheless. Okay, well, cool. I think what I'm going to do. Let me see if I'm going to look outside my window here. Let me. I'm going to stop sharing my screen, and I'm going to go back here, and I'm going to look outside my window and see. Oh, I still got. No, I've still got a big, huge cloud right where I want to be looking. So, dang it, I don't know if that bright object is there still or not. And look at that, I'm a little tilty. I'm gonna have to work on that a little bit. Let's go up a little bit. Here we go. There we go. Okay, well, cool. So yeah, so I'm getting a couple of new things for my system. I guess I can give a little bit of an update on my project to characterize this system too. I've been having a lot of trouble with trying to get the photometry to match the photometry of Gaia, right? I mean, Gaia, I would say, is a pretty trusted source, right? I mean, they've made measurements of 1.8 billion stars, and they've measured the magnitudes of most of them, and yeah, I mean, I guess I sort of have to trust their measurements, and I do. So when I make measurements of some of those stars, right, and I compare my measurements to theirs, I can say that my system is working well if my measurements match Gaia's, at least, to some degree, right? And what I'm aiming for is anything less than about 1/10 of a magnitude or so. So if I can get, my measurements accurate to at least 1/10 of a magnitude or less, right? I mean, preferably less. And those measurements are consistent, right? I don't want them to be, like 1/10 of a magnitude and then, 0.15 magnitudes and then 0.05 magnitudes. I don't want a lot of variation, right? I want it to be consistent and also very, very close to Gaia. And so I've been doing that the past couple of months, and what I have found is that some of my measurements are very accurate, less than like 0.05 magnitudes, and some of my measurements are just absolutely horrible. Half a magnitude off, 1 magnitude off. It's just completely bonkers, right? So, and it's sort of been driving me crazy, trying to understand why there would be any kind of differences. And so one of the things that I thought, after sort of trying to eliminate all kinds of possibilities, it's like, well, maybe the stars that I'm looking at are slightly variable, right? I mean, maybe even over long periods of time. So when Gaia observes them, they're at a certain brightness, and then later on, when I observe them, they're at a different brightness. but I haven't completely eliminated that possibility, but one of the things that the Gaia database does provide is a little flag saying, this is a variable star. So there's kind of two problems with that. Or maybe just one. Yeah, there's one big problem with that, and that is they haven't done this for all the stars they've observed, right? They've only done it for a few. So so as I said, that's still a possibility. But this past weekend, I started looking hard at my code, right, that actually makes the measurements. And I actually found some at least a couple of problems that, excuse me, that would actually cause my measurements to be different than Gaia, and it has to do with actually how I'm making the measurement. Now, I think at some point I probably do want to do some kind of live stream explaining all that, and maybe we can actually look at the actual code. It's written in C, so I mean but it's pretty simple, right? I mean, there's not much to it. I'm basically just looking at the pixels that make up a particular star, and I'm looking at the values of those pixels, and I'm adding them up. Right, that's all I'm doing. So yeah, maybe at some point soon, we can sort of go through the code. If you've never seen programming code and C and all of that, maybe that'd be slightly interesting. I don't know. I know that there are programmers, I think especially on Twitch, that are writing code, and they have a bunch of viewers, and I guess I guess that works. And I actually thought of that probably about a year ago or so. It's like, maybe I should just live stream writing code. And but my my thought at the time, without researching it much, I was like, I don't think that people are going to be too interested in that. I mean, it's like, almost as bad as watching somebody eating, right? It's like, I don't know, and maybe I've got a little bit of a bias because I am a programmer. I'm not particularly interested in watching somebody else writing code. Even if I could learn something or anything else, it's like, I don't know. But maybe that's something I can sort of try. But I mean, for a live stream here, right, doing it once every, I don't know, couple of months or so, yeah, maybe that might be a little bit interesting or so. So what am I trying to see better? With the focal reducer, what that'll do, as I said, is it'll increase my field of view to, say that to twice that amount, right? So it's actually 4 times the area. So I'll just get a wider field of view, and with a wider field of view, I just get more stuff, right? If I want to eventually get into doing any kind of work with like extended objects, like galaxies or nebulae, having a nice wide field of view so I can actually see the whole thing, that is really, really nice. The other advantage to having a wide field of view is that it's sort of easier to move around and find things, right? I mean, this scope does just sort of a mediocre job of pointing, right? So, you know, when I tell it to go to a particular place in the sky, I can't be absolutely sure that it's actually pointing to that place in the sky. It might be off, right? And if I have just a really, really narrow field of view, right? Well, if I'm, you know, if I point the telescope and I want to be here and I'm here, it's like, well, I'm not gonna know, and it's going to be kind of hard, you know, to move around and find that spot I actually want. But if I have a wider field of view, then I have a better chance, you know, even if the pointing is bad, I'll have a better chance of actually seeing my target in that wider field of view. So there's that. With the mask, with the Bahtinov mask, that is simply to allow me to focus. So at the beginning of the observing run, of course, and then possibly during the course of the night, right? I can throw that thing on there, check the focus, take it off, and go. So yeah, and Atta, a lot of the accuracy in pointing has to do with how accurately you do star alignment. So I've sort of noticed that, is that, you know, when I'm really, really, really careful with the star alignment, the pointing seems to be a lot better, and that just makes sense. That just makes sense. So the other thing, for me at least, is when I switch between filters, right? Because my camera has a filter wheel on it. When I switch between filters, well, each of the filters has a different thickness to it. So what that does is it actually changes the focus. So when I go from one filter and focus on that, well, if I want to switch to another filter, I have to refocus. And I want to be able to do that fast, right? I don't want to have to diddle with it, and it's like, you know, okay, I've got to go way out of focus, and I've got to go way on the other side of focus, and then, you know, it's back and forth, back and forth. This way, I'm going to be able to see exactly, right? And I can go, zoom, and I'm done. And that will just save a lot of time. So it's a time saver. You know, that's basically all it is. It's just a time saver. Instead of spending, you know, several minutes trying to focus, I can spend a few seconds, and that's nice, right? Because I mean, I want to be able to collect data. I don't want to have to be able, or I don't want to be forced, you know, to diddle with the focuser. So cheers to focus. Yeah, not all filters will do that, but yeah, that's pretty common. So yeah, every time you change something in your optical path, even the eyepiece, right? You usually are going to have to refocus a little bit. A lot of eyepieces are sort of designed such as to minimize that, but oftentimes, even changing the eyepiece, you're going to have to play with the focus a little bit. That's just a common thing. And the same thing with filters. Exactly the same. Exactly the same. Same thing. Any time that can be saved is a good thing. All right. Well, cool. I'm gonna glance out my window again here. See if I can't tell now. It's sufficiently dark out that I can't tell if it's a dark cloud or a dark sky. It's probably dark sky out there. But yeah, I'm pretty anxious to get back out there and see if that bright object is still there, because if it's still there after over an hour, then I'm going to go insane. So because that's something. that's really yeah, that's something extraordinary. So cheers. Let's see, what else should we we've got well, we've got a few minutes. Why don't we do an object of the day? Object of the day. What should it be? We can do a Messier object. We haven't done a Messier object in a while. Object in a while. Do an NGC object. We just did an NGC object the other day. So I'm kind of thinking maybe a Messier object of the day. What do you think, Bobby?
Let's do it.
All right, let's do it. I'm reading Tom's comment about developers on Twitch. Some are pretty good at keeping the viewers involved. Some jump around too much. Yeah, Tom. You know, I think that I would be in that latter group, because I think I do sort of tend to jump around a lot. What I would want to do, you know, if I were to do any kind of streaming with programming, is I would want to start from scratch, right? I would be like, okay, let's write a program to do X, right? Some kind of thing, and it can be anything, right? And then do the whole thing, run through the whole thing, and you know, if it has to be broken up into, you know, episodes or anything like that, fine. But yeah, I would definitely want to do that. And again, it wouldn't be a thing where I would be trying to teach anything, you know, anything like that. It would be a problem that I would want to solve, and write the code, you know, beginning to end. I don't know. Parachuting spider. Yeah, I don't know if I've ever seen a parachuting spider.
There's a thing on one of my shortwave radio shows I listen to that it says something. It's called shortwave radiogram. They do digital text and images, and they were saying about having a ballooning spider.
Interesting. Yeah, you know, I just I watched my first shortwave radiogram show the other day, and you know, got to admit, I didn't get through the whole thing. I need to. It's kind of. I guess I probably have to approach it in sort of a different way. But it's you know, I don't like to call it noisy, but you know, it's a pretty interesting sound, and but it's kind of cool. It's kind of cool. I'm going to have to check it out a little bit more.
Yeah.
That's
YouTube
something
starting tier 6 usually have those videos and stuff.
cool. Yeah. Yeah, I'm going to have to check those out a little bit more. Because I could probably definitely get into that kind of thing. So yeah, very, very cool. All right, let's do a object of the day, and let's pull from the Messier catalog. I'm going to share my screen. I'm going to hide that. I'm going to mute Bobby again for the feedback. Sorry. And then let's go over here to random.org. Random.org. So there's 110 Messier objects. First catalog by Charles Messier back in the mid 1700s. He was a comet hunter, and he saw these things that were bright. Some of them were fuzzy, but they didn't move like comets. So it's like, okay, I'm going to write these down so I don't confuse them with comets. So, and these turn out to be very, very bright non-stellar objects, right? So they can be galaxies, globular clusters, open clusters, planetary nebulae, gaseous nebulae, that kind of stuff. So let's see what we've got here. Ready? Bang. Oh, M97 is a good one. That's the Owl Nebula. It's a planetary nebula up in Ursa Major. So that's a nice one. Let's do the Sinbad thing. Whoop, not G Sinbad. M97 is a pretty one. And as I said, it's a planetary nebula. It's the sort of the remnants of a dead star, of a star that has sort of not necessarily exploded, but has just ejected its outer layers. So yeah, here's a pretty good shot of it here. Now, I'm looking at these magnitudes, and I gotta say that I don't think that these magnitudes correspond to the nebula itself. I'm thinking that these magnitudes correspond to the central star. The central, it's probably a white dwarf star that is left over, right? All the outer layers of the star have been blown off, and what's left can be what's called a white dwarf star. And my guess is that that's what these magnitudes are, because I'm telling you, M97 is much brighter than that. Much brighter than that. I mean, you can easily see this nebula with a 4-inch telescope. I mean, pretty easily. So, and for sure, you cannot see a 15th magnitude object with a 4-inch scope. No way. So my guess is, not quite sure why they would do that, but there it is. As you can see, it's pretty big, 3.3 arc minutes in size, so that's really, really, really big. It does have some parallax, right? 1.13 milliarc seconds or so. Oh, I've got somebody knocking at my door. I think I'm going to have to play doorman here for just a second. Hold on. we must submit to our kitty overlords. All right, well, you can see the right ascension here and declination. It's way, way, way up in the north. As I said, it's in the constellation of Ursa Major. It's actually sort of at the bottom of the bowl, right, of the Big Dipper. Let's see. So let's go down. Here's a bunch of other names for it. Bunch of other names. I think it's got an NGC number. Yep, 3587. And a bunch of other ones too, of course. A few references, just a couple. Let's look at. Let's see. So we already have a parallax measurement, right, which is 1.13. But here they actually have some actual, well, some numbers, and they don't really. There's not a lot of agreement there, right? 879 versus 621 parsecs. Let's get that into light years, right? A parsec is 3.26 light years. So let's see, 879 parsecs is about 2865 light years, and 621 is about 2024 light years. So yeah, quite a bit of disagreement there between those two measurements. It looks like this measurement was made in 2008 and this one in 2018. So can we trust the more modern measurement? I don't know. Look at these error bars though, plus or minus 51 parsecs. So if we subtract 51 from there, we're going to be getting down to 828. So 828, 621, that's still quite a ways away. So yeah, not quite sure why there is such disagreement. I guess, you know, we could look at it that way too and see if the parallax corresponds. Okay, this looks like the same paper, right? 2018, I'm not quite sure what that references, but 1345, is that the same one? Yeah, it's the same one. So yeah, don't know why there's some disagreement there, but there is. So it looks like it's moving away from us at about 8 kilometers per second, which really isn't that much. Not moving that much at all. Yeah, I'm thinking that I'm looking at the temperature here. These numbers here, this T effective and this log G. T effective is the temperature in Kelvin, right? So 65,000 degrees Kelvin. That's the temperature of a white dwarf star, right? And log G is the gravity of that object relative to the sun in a log form. So it has a gravity 10 to the 8th times the gravity of the sun. So huge gravitational field and extremely hot. We're talking white dwarf. So yeah, these are the measurements of the white dwarf for sure. For sure. Let's see what else we got here. So yeah, you know, this is a beautiful nebula. I definitely encourage any of you that have a telescope to take a look at this. And as I said, even with a 4-inch scope, you're going to see something. The darker the sky, the better. The darker the sky, the better. If you have a filter like an oxygen 3 filter, that that will help in sort of allowing you to see this. And this object is typically called the Owl Nebula. And the reason why it's called the Owl Nebula is because of these two dark areas here. It sort of makes it look like an owl with these big eyes. Now, when you look at this through a telescope, right, it is not going to look like this, right? This is a long exposure. I mean, it's probably pretty close to true color, but it's still colorized, right? I mean, what they've done is what I do here, and that is, take images in, 2 or 3 or more different filters, and then say, okay, this filter is red, say, this filter is green, this filter is blue, and then combine them, right? And you get this. So this is definitely not what it's going to look like if you look at it through a telescope. But you will definitely see that you'll have an extended object, a fuzzy extended object, and if you look carefully, you'll be able to see those dark areas here too. Now, with like an 8-inch telescope, or a 10, or a 12, or a 16, you'll be able to see a lot more contrast, right? So these darker areas will pop out a little bit more than using a 4-inch telescope. But yeah, it is quite a sight to see. And actually, right next door, almost right next door, I'm going to zoom out here a little bit. There's another Messier object pretty close. Let's see if we can get these guys in the same field and still see them. Dun, dun, dun. So there's M97 still. Where is he? Is this him? Yeah, I think this is this guy down here. Is it this guy? Yeah, that's a star over there. Pretty sure this is M108. This galaxy right here. Pretty sure this is M108. So we're getting two Messier objects for the price of one here. And there's another one right next door, but this guy's really, really bright. I think that's M108. Should we confirm that really quick? I would like to. Don't want to. I mean, I don't care if I'm wrong, but I just don't want to steer you guys in the wrong direction. I appreciate being wrong. As a scientist, I greatly appreciate that. Oh no, okay, that was not M108. M108's got to be back even further, huh? So there's M97. M108 is around here somewhere. I know it is. Huh. Because these two stars here are the two stars in the bottom of the Dipper, right? And there's M97. I thought M108 was around here somewhere. Maybe I'm just completely bonkers. Is that it? Maybe that's it. Come on. Come on, you. Oh, that's not it either. Well, let's do this. Yeah, M108's nice, big, and bright, but where is it relative to 97? Oh. I don't know. Is that it here? Yeah, that's it there. I'm just completely off my rocker. I probably am. Zooming out even more.
Uncle
Oh,
Bill's
well.
M108 is 48 degrees northwest of M97.
48 arc minutes. Arc minutes. Yeah. I know it's around somewhere. West-northwest. Huh. 48 arc minutes west-northwest. It's got to be really close then. Huh. Let's, I'm going to, well, all right. Well, I'm not going to dwell on this too much. Yeah, I'm not going to dwell on this too much. M97 is absolutely fabulous, though. Great object, to see in a telescope, for sure. Pretty well studied. Pretty nice looking. Pretty nice looking. Great structure, right? Really amazing structure. And these colors, right, are telling us about different kinds of material, different kinds of stuff. And so it looks like, on the outer part, see how it's a little bit more green? That is different stuff than there is in here. So, why is that, right? And then even within that, you're seeing, interesting, I don't know if those are holes or what. There's all kinds of neat looking things in there. Yeah, M97 is absolutely fabulous. Absolutely fabulous. Good Messier choice. Good Messier choice. And if you live in the northern hemisphere, for the most part, if you live above 40 degrees north or so, you can pretty much see this any time of year, right? It's almost circumpolar, right? Now where I am, down in southeastern Arizona, that object and actually that constellation does actually dip below the northern horizon for a little while.
Uncle Bill said go 40 arc minutes north and then 30 minutes arc minutes west to the right.
Okay, all right. It's got to be about in the same area then. I'm just not seeing it. Let's try again really, really quick. Drive me crazy. So that field of view is 27.1 arc minutes. That field of view is 54.5. So if you're right, Uncle Bill, it should be in this field of view. And I don't think it is. No, it's got to be a little bit more than that. Is that it? Yeah, that's got to be it. I was just looking. Yeah, that's it. Okay. Man, I knew it was there. Driving me crazy. I was just looking in the wrong place. So there it is. So there's M97 and there's M108. Yeah, very cool. So yeah, you can see both of these easily, right? The cool thing is, just to put this into perspective, right? This object is inside of the Milky Way, and this object is way outside of the Milky Way. So this guy is really, really close relative to him. So just to give you a perspective, give you a little bit of depth, right? This is extremely far away, probably millions of light years away. This is, what, a couple thousand light years away? Yeah. So pretty cool. Pretty cool. Thanks, you guys, for helping me out with that. I knew it was around somewhere. I was just looking the wrong way. All right, cool. Let's, now we're definitely running over time a little bit. Let's just see, let's look at the newest stuff. Atlas of monochromatic images of planetary nebulae. Man, we could get lost in that. Chandra, that's a X-ray observatory in orbit. So it has been looking at this nebula in the X-ray. Very cool. You know, at those kinds of temperatures, right, you would sort of expect to see X-rays, high energy stuff. Let's see if there's any other interesting recent things. Not seeing too much. I'll bet you I'm absolutely certain that the HST has looked at this a lot. We'll get a count here of how many observations HST has of M97, and then we'll call it a day here. I'm sort of anxious to get outside and see if that thing is still out there. So all images, all spectra. Guaranteed that it has seen it. Yeah, it's taking it a long time too, which means it's a long list. Either that or the internet is really slow, but I doubt it. The Rose returned 1. No, that's a lie. Let's look at the NGC number, 3587. Oh, it's looked at it more than once. Oh, give me a.
At the top of the page, it says it got some scheduled maintenance real soon. It's in the red.
Oh, I see. Wednesday, August 22nd. Well, that's well, I guess that is now, isn't it? It is 3:18 on the 22nd of August 2018. So yeah, maybe that's why. I was expecting a lot more than 1. Okay, well, whatever. I think it is time. I think it is once again time to get on out of here for now. So thanks everybody for coming in again, sharing this passion that I have for all things astronomy. It's just, I mean, I thoroughly like to share this, and man, I could do this for a lot longer, than an hour or so, but time is valuable, and I don't want to bog down everybody's time here, so I like to keep it a little short and sweet. Let me okay, I just wanted to check the chat one more time. So all right, I'm gonna get out of here for now. So thanks everybody for coming in. Greatly appreciate the support. If you're new and viewing this for the first time or the second time or the third time and haven't subscribed yet, make sure to subscribe, because I am here every single day at 2 hours UTC. Usually go for about an hour, and we think and talk astronomy pretty much that whole time. So all right everybody, I'm going to get out of here. I'm going to go and look and see if this thing It's still out in my sky. Very, very likely that it's not. If it is, I'm gonna go absolutely ballistic and probably be observing it the rest of the night. So all right. Take care, everybody. I will see you on the spin. Bye.